Hello everyone. In this video, we are going to discuss container with most water, and this is the 10th question in the list of arrays in 75 LeetCode question. So yeah, let's start diving deep into it. All right. So as we can see here, I would like to follow these 8 steps, and this is the most important one where we actually write down all the test cases and edge cases. And okay, let's start with the first step, which is reading the question and understand the question. So you are given an array height of length n. Okay, height. There are n vertical lines drawn such that the two endpoints of I line are I and height I. First two lines that together with x-axis form a container such that container contains the most water. Okay, return the maximum amount of water container can store. You may not slant the container. Okay, so looks like the input that they are giving us is a vector of int. Output they are asking is just an integer of maximum amount of water a container can store, and this input is basically height at each index. So in this, let's say this, we can see at 0th index the height is 1, then 8 is height at index 1, then 6 is as 2, and then we have to figure out what's the maximum water it can be filled, basically length multiplied by breadth. So in this one, if you see 7 minus 8, this is first index, this is 0 1 2 3 4 5 6 7 8 8 minus 1, so width is 7 multiplied by the height is 7, so it comes as 49. So that's the max answer that we have to return. We cannot return this answer because this is not the max. We cannot return this answer because it cannot be max. So okay, I think we have a good idea of the question, and if you see, the input that they are giving us is always greater than 2, so that means we don't have to worry about one and like one input, it has to be empty. So okay, now let's look for brute force. So it's array given like 1 8 6 2 5 4 8 3 7. So if we can iterate this array, if we can figure out all pairs, all possible pairs in this array, and then for each pair we can just take the minimum of their height, multiply by the difference between their indexes. If we can keep track of this value while we generate all the possible this, then we can just return this value and it will be the answer. So brute force, I would say big of n square, where we run 2 for loops, and once we have I and j, we just calculate, like this for loop will be I, this is for j. We can just calculate height is equals to minimum of nums I comma nums j, and length, or I should say breadth, is equals to j minus I, and then we just multiply that. So let's say if it's 1 and this, then it's like, I'm thinking, yeah, should we start the indexing from 1 or 0? That's what I'm trying to think, because this area 0 1 2 0 1, this area will be left is 2, this is 3, so that works. 1 minus 4, this is 3, 1 minus 3, this is 2, so 0 minus 8 is 8, 7, 1 2 3 4 5 6 7 8. Yeah, that's good. We don't have to worry about that, so we'll just start from 0, and this is going to be I plus 1 j, and j will be taken care of. So brute force is big of n square time complexity, but is there a way we can do this in big of n? I think we can. let me start big of n solution. So let's take the same example, 1 8 6 2 5 4 5 4 8 3 7. So what we're going to do is start 2 pointer from front and back. Now this becomes a mathematical question here. Area is equals to, let's say, breadth multiplied by height. Now at every in point, the height is always minimized by the smaller building. Let's say if we want to calculate the area between L is equals to 0 and R equals to 8, then doesn't matter what the width is, height we cannot go more than 1. So if you think about it, height is always decided by the smaller of the two buildings, while breadth is just decided by the width or like indexes that are two buildings. So this algorithm, what we're going to do is start from initial and end. Let's take let me run a code here. 1 8 6 2 5 4 8 3 7. This becomes 0 1 2 3 4 5 6 7 8. Now what I'm going to do is start with L equals to 0, R is equals to 8, and then we'll take max volume. Let's say it's int min. So when L equals to 0, R equals to 8, what we're going to do is minimum of these, which is 6, and actually area, and then max area. Yeah. L equals 0, R equals to 8. Area will be 8 cross 1, which is 8 is the width and 1 is the height, so this will be 1. Now this will change 8. Now the thing is how to move the indexes. So we are already, whenever we move L and R closer, we are already decreasing their distance. That means the value breadth is decreasing. And in order to maximize area, if we are decreasing already this, we should increase this. And in order to increase this, we need to move the index of the smaller building in forward, because that way we can maximize the height. If we move, because it doesn't matter what comes on the right side here, the smaller building will always minimize. Let's say the smaller building will always minimize the height. So let's say an example where 1 2 9 5. Let's say we are standing here, left and right. We say 0 1 2 3 4 0 1 2 3. 3 minus 1 is width is 2, and then 2 is to 4. Now the thing is, if we move bigger size here, then what will happen? This will difference width will become 1 and height will become 7. And if we move this to here, this will become 4. Just trying to think here. 1 2 9 5 is given. Yeah, this will not be 7, this will be 2, because once we move R here, this will be the limiting factor, so it will just say 1 into 2. So, and also we're going to miss the case of 9 and 5. But if we move this to here, 5 will keep it up, 5 into 1, so which will be 5. So basically, what I'm trying to explain to you guys is, if we are already decreasing breadth while we are closing down the window, we should maximize the height. And the way to maximize the height is by moving the smaller L or R, whichever is pointing to the smaller, to the right or left, so that we can get the so that the chances of the bigger building coming up into the play are good. So in this case, what I'm going to say is if L equals to 0, R is equals to 8, we check area 8. Maximum area becomes 8. Now we need to move here. L becomes 1 and R still remains 8. Now here what we're going to do is 8 minus 1. 8 minus 1 is 7 and 2, 7. It becomes 49. What would have happened if we have said L equals to 0 and R equals to 7? Think about it. 1 will still be diminishing factor. So what the area would have been 1 star 7, which is 7, which is still smaller than what we got originally. So we should always move the index with the smaller height so that we can maximize this. All right, looks good. Now let me code this out for you folks. So let's see what variable we took. We'll take int max volume is equals to int minimum, and then we're gonna start L is equals to 0, R is equals to dot size minus 1. Now what we're gonna say is while L is less than R, I don't wanna be handling the case of equals to. What we're gonna do is say width is equals to R minus L. That's easy. Height is equals to minimum of nums L comma nums R. Then we say current area is equals to width star height. Then we'll say if current area is greater than max area, which is this one, max area. Then we say max area, we found a new max area, which will be from current area. Now once we have done this, what we're going to do is if nums of L is greater than nums of R, we're going to do R minus minus. Else, let's say L plus plus. And yeah, at the end just return max area. So if you see worst case scenario is big of n, and hence it's a time improvement. Now let's code this out for you folks. Quickly go through a submission. We take max area, we take size. This we don't have to do because we saw max area equals 0, less 0, R equals to height size minus 1. We start this loop. If height L is less than height R, we check the minimum difference, new area greater than this. If height L is height R, yeah, so this looks good. Let me go through this again. This is, even if we remove it, shouldn't break anything. The max area initially is 0. And then 0 is the minimum area possible. We can also do this. We can also do this as let me just do it that so that it's easy. Minimum possible value. And then left 0, R0. It's always going to be more than 2. So min equals to 0. What is min here? Okay, min is set here as the height, whichever is min. It can be also done as just improvising the code here. Height R, we can delete this. Minimum of height or light difference is R minus L, which makes sense. New area is min star diff. New area is greater than max area, then do that. Height L is yeah, this should not, if the only case it failed, it should be when it's 0. Height L is less than height R, that means we need to increase L or less. Let's run this code. min should not be this. Let's say min HEIGST. Let's do that. And min height. It can be here. Let's run now. All right, let's see. Submitting. All right, it works. So seems like this was an improvement. And we are using the C++ inbuilt min function here. So it is pretty fast. Try to reduce a few lines here. 1768, 1773, pretty fast. Good code. I would say, yeah, big O of n solution that I just mentioned is like the mathematical part of it is very complicated to understand. So try to write down more edge cases and run this code through those edge cases and you should be good. But yeah, thank you everyone. If you have any questions, paste the comments, add in the comment section. Thank you.